Ladies and gentlemen, we move on to our next leadership keynote, Accelerating Digital Transformation with Hyper-Contemporary Technologies. And our keynote speaker is Mr. Koushik Basu, Executive Vice President, Global Delivery, TCG Digital. I will request Mr. Koushik Basu to kindly come on stage. He's going to be speaking on accelerating digital transformation with hyper-contemporary technologies. Please put your hands together for Mr. Koushik Basu as I welcome him onto the dais.
Thank you very much. First of all, let me thank all of you for staying very patiently to hear me out in this session. Before I start, maybe a brief introduction about myself would be in order. So I am a Kolkata boy. Went to school here in Don Bosco. Then I did my engineering in IIT Kharagpur. I joined the IT industry way back, more than 25 years back. Started my career in Salt Lake Sector 5, in PricewaterhouseCoopers. Then when IBM acquired the consulting practice of PwC, I set up the service lines in IBM India. After that, I went to the UK, where I was responsible for the consulting services in Europe for high technology and telecoms, right? And then in my career, I have worked across multiple industries, focusing on digital transformation. So I have a perspective, which I wanted to share with this audience. And the perspective has been formed based on my work experience. So most of what I'm going to talk about today is based on what I've seen implemented in corporations across the world. I think where we are today, I call it an inflection point. And the reason I call it an inflection point is we have hyper-contemporary technologies which have matured to a point where I think a lot of new opportunities have opened up, and for all of us, right? And from my experience, where I worked in telecoms, in oil and gas, and now I am responsible for AI and ML applications working out of TCG Digital. I see at this point in time a huge opportunity for all of us in terms of looking at what technology can provide in terms of capability, but also identifying trends in those capabilities and gluing or stitching together those capabilities to come up with outcomes which are of interest to all of us in the business world. Now, let me just quickly, there's a lot of words here, but just to take on from what I said before, we are at an inflection point. And today I'm going to talk about 4 key technologies and probably end, because I have 20 minutes, I'm going to end the presentation with some examples from the real world where we will see how these 4 pillars of digital transformation converge and actually deliver value to the industries that we work in. Cloud computing, right? And I've just, instead of getting into the technical details, I wanted to just give you my perspective from a user's perspective, how this has changed. When I started my career, cloud computing was all about moving from desktops to servers in the back office to hosted environments provided by cloud providers like Amazon, like Microsoft, etc. So that's something we all understand. From our perspective, we used to buy licenses for Microsoft Office. Now it's subscription-based, right? In the previous, I don't know if you are as old as I am, when I first brought Microsoft Office and I loaded it on my laptop, there were 16 CDs I had to put one after the other into the drive so that I could install Microsoft Office. Now it's done in a click of a button. In fact, the software is not even on your desktop. You're actually using compute elsewhere, right? I'm going to talk about some examples later in terms of what that means for us. Big data. This is, again, something that has been around for a long time. Those of us who have been in IT, we have actually worked with big data, or we have been working with big data without even knowing it, right? So if you look at it, in the old not even old, maybe 10 years back, 15 years back, we are relational data stores, right? And when we used to build applications, we used to build applications where we used to store structured data. Now, data comes in all types, right? So it's structured, it's unstructured. And more importantly, it's no longer the data, it's the context around the data. So just to give an example, right? I make a transaction on Amazon, right? That's fine. So I buy dishwasher tablets from a dishwasher, which is what I did yesterday, right? But what is more important is my profile. What kind of profile do I have, right? Where did I buy it? At what point in time in the day did I buy it? What other things did I buy? What did I buy before? In fact, if they want to track, right? What our customers with my profile are buying? What brands are they buying? So just this one transaction, this was what we would have stored in the past. Now we are storing other contextual data around that transaction. That's also what's driving big data, right? And why are we doing this? Because compute and storage is so cheap nowadays, right? And let me walk around a bit, right? Because I want to also be alert, right? So storage is cheap. And I talked about the example, right? So where in the old days, CD after CD after CD. Now, it's not really an issue, right? And you pay for per use. So again, cloud computing, big data coming together. AI. AI algorithms. When I was in the US, when I did my master's, I worked on AI theory in the late 90s. So we had AI, right? But we couldn't commercialize AI. The fact is, the algorithms that you see in AI applications were most probably discovered, invented in the 2000s, even in the late 1990s. What's happened today is, because we have big data, we can store it on cheap storage. We also don't need to buy anything. We have compute on demand. We have storage on demand. We have networking on demand. This means that we can now apply AI algorithms which were discovered or invented years back today, right? I think there was a speaker before me, and there was a talk about ChatGPT, right? ChatGPT, if you look at it, the actual details, it's a large language model. It has been trained with humongous amounts of data, right? And that's possible because, not just because of the algorithm that they're using or the LLM that they're using, that's because the other two are in place. And finally, IoT. This is very important. If you look at the trends, right, of digital transformation, when we first started talking about digital transformation, I was a consultant, right? And I used to sell digital consultant projects to customers worldwide. We used to talk about digitally transforming the workplace. So if I think there was a panel for marketeers or the marketing, the CMOs. So we looked at, how do I transform the marketing office? How do I transform my finance office? How do I transform my logistics office? Right? And then more importantly, how do I bring all of this together? That was some time back. Then we said, okay, that's done. What next? And as consultants, we have to always think about new ideas, right? To be relevant, right? So that we can continue to sell our services, right? And then the next wave was, you transform the front office and the extension of the front office, which is the ecosystem around the company. So it's not just how well my marketing department is performing. Fintech companies, right? Companies which exist by orchestrating transactions between companies. Companies which exist, digital marketing companies, by selling data about products and services to other companies. This was the second wave of digital transformation. So we'll focus not just on our company, our departments, but how do we operate across? How do we operate in the ecosystem? And finally, the third wave is when we actually look at bringing in machines, which is the IoT wave. Right? So that's the transformation that's happening in the industry. There are some detailed slides here. Some data points. I talked about big data, talked about volume. The important thing is the variety, right? And I talked about unstructured data. I talked about all of this. The key thing here is that people now understand the value of digital transformation is mining this. And the most important part of understanding the data is, because data is so cheap now, right? You can just store it on the cloud. So let's say the number 29. What does it mean? The temperature of the day? Does it mean my age? Does it mean the number of dishwasher tablets that I bought yesterday? That's the context. I don't know. That's probably more important, right? So, and also, the technologies have evolved, so we can store all of this, whether it's structured data, textual data, network data, time series data, you name it. Sorry. You can store it. And the velocity, someone told me, and I'd read this somewhere, that since the dawn of civilization, since till, let's say, the early 2000s, the amount of data that was generated, since the dawn of civilization, since 2002, 3, the amount of data, that's the same amount of data we are generating today per day. Just to give you some context, right? Cloud, I talked about some context setting there. Uber, Netflix. I mean, this is the reason we put this there is because you will relate to this. In Uber and Netflix, what's common? The common part is nothing is constant. The number of rides that happen at a particular hour in a day, in a month, in a year is not constant. They, in fact, have something like, they have surge pricing. Netflix, the patterns of viewing change per day. I was in a telecom company. You know what they're doing? You have this telecom towers. We all see that for mobile phones. They're virtualizing the radio and the backbone, which you don't see because fiber optic underneath the ground. They're putting that in the cloud. And what they're saying is, if a lot of people go to Eden Gardens to watch a World Cup match, and they're actually taking video, they're taking snapshots, they're sharing it with friends, then traffic surges. If I can temporarily move more network dynamically when the match is going on, my user experience, because I used to consult for operators, right? Big operators in India. My user experience goes up. So if someone is on, let's say, I'm on Airtel, someone is on Jio, and the user experience for my phone is different from the other phone, you automatically get a lot of marketing. But all of that is possible only if you have everything on the cloud. So that the key word here is we can dynamically adjust the workloads that are going onto the cloud. IoT, this excites me. And I'm going to spend probably the last 5 minutes just talking about some use cases. Again, some numbers. 75 billion connections, $11 trillion. And and some of you may have heard about connected devices, right? So if you have Samsung or iPhones, you will have connected devices apps. If you go to a power plant, if you go to a refinery, right? There are so many devices or machinery out there. If you think about putting IoT devices on each device, or each machine, sorry, which measure temperature, pressure, vibrations, etc., all of that in real time, I can think of an app that I can probably gather a lot of stats and apply AI, ML to cut down my operational costs. All of that will be possible if I have these IoT devices talking to each other and to a centralized server somewhere through good connectivity. And also, I should be able to store the data that's streaming in from all of these devices on cheap storage on the cloud. Again, the thing is, all these four hyper-contemporary technologies are working together, enabling solutions. AI, I think this is a vast subject by itself, but I just wanted to give you a flavor. I don't really want to talk about it. AI is nothing new. So we had AI around for a long time, but the important thing here is, this is the data. Data is like, what we're trying to do with AI is look at patterns. That's the nirvana. That's what we're trying to do. There are classical methods of looking at AI, but it's always an approximation. What AI now allows you to do, the algorithms that we now have, allow you to look at multiple patterns at the same time. I'm putting it in a at a very high level, but looking at patterns at a high level, and basically, based on data, historical data provide predictions which we wouldn't have got otherwise, right? You could actually have statistical predictions, but statistics, by definition, regression paths, right? They fit a particular curve. It may be linear, it may be non-linear, but it fits that curve. So there will be, by definition, data points which don't fit that curve. And that's how our human brain works, right? We are we can recognize images much quicker and faster, right? Because we can deal with, if I look at a photograph with half of the face hidden, I can still recognize that person, because my brain can fill in the other half. Statistical algorithms won't be able to do that. And that's where AI comes in. Now, when we talk about digital transformation, I gave you a flavor of we are living at a point in time where we now have an opportunity, with all these technologies have come together. When you look at it practically, right, the first thing you need to do is get the data. And this data could be plant data from your manufacturing operations. It could be data from your consumers. It could be data from your back office. It could be contextual data flowing in from social media. It could be anything. Get the data in. That's the first thing. Store it. And then someone needs to monitor it, either humans or robots. That's the first step in my digital transformation journey right now, in the new world we are living in. The second step is, once you have got the data, you can start utilizing the data. Maybe some dashboards, right? Maybe some simple computes, which look at the data. So if you have plant data coming in, you can have alerts, right? So if my machinery A has a capacity of X, if it's below that, I will get an alert, which is my control. Optimization is where AI comes in. So I've got all the data in, I've got the historical data, I've got some understanding of the quality of that data. Then I can start thinking about AI algorithms to optimize the process which is generating the data. Data without a process doesn't have any meaning. So the ultimate objective here is to optimize the process. It could be I'm trying to sell something on the web. It could be I'm trying to optimize a process within an oil and gas refinery, which I will come to later as an example. It could be also something like optimizing an airline operation, like minimizing the number of baggages that don't arrive in time. It can be anything. And this is what I'm trying to say. It's your imagination. It's not limited now because we now have the technology. You can think about whatever you want to apply, and then the technology should be there to support. But you can't do that in the big bang. You go through what I call this maturity curve. And finally, autonomy, where you have, I call it AI square. AI controlling AI, which is then you don't have human intervention. You have something called a closed loop. So you have an optimization process, you're making decisions on what is needed for optimization, and you're letting the AI actually implement it in the real world. So in my example, if I think that by changing some parameters in an industrial process, I can increase the yield of whatever I'm manufacturing, I don't want a human to actually implement the recommendations. I will use an AI agent to actually act on it. Financial services. I'm a trader. AI discovers a trading opportunity where I can make a lot of money. The AI agent executes the trade. I don't. It's a leap of faith. But that's what we are talking about when we say autonomy. And that's where Industry 4.0, and you will have heard the term to Industry 5.0 comes in, because 5.0 is about ethics. To what extent will we allow AI to take control of our lives? I think someone talked about ethics in a previous session. What is needed for all of that to happen is, from a technology perspective, and I need to talk about technology a bit because this is an IT session, is you need to look at all sorts of data that needs to come in. You need to look at storing all of that data, which can be of different types. And I talked about the fact that you have different kinds of storage requirements now because you have unstructured, structured data. Then you have data management, which is all about MDM, making sense of what you have stored. Data contextualization, which is making a lot of sense. We call it putting a domain context to it. I give you an example of the number 29. What does it mean? Number of dishwasher tablets, my age, it can be anything. It's the context. And then once you all of that, then you apply AI and ML to mine that data. And then you have a dashboard or any kind of visualization tools to allow you to look at what that data actually provides in terms of intelligence or optimization opportunities. So, sorry. One second. Yeah. So for us, when we talk about digital transformation, this is what we need. In my current role, in my current company, what we are doing is we have a product called TCG MQ, where we are actually trialing out all these use cases. But the point is not the product. It's the fact that you should have a set of capabilities which are integrated. And because all of us should be focusing on the business value, not on the IT side. You should look at platforms which actually deliver all of this out of the box. These are real examples. This is the largest airline in the world. For confidentiality reasons, I can't talk about the name. But as you can see here, this is a typical business transformation journey that this airline went through, right? And this is over 2 or 3 years. And it's cutting across sales and commercials. That's the back office, airline operations, back office. Sorry, sales and commercials, back and front office. Airline operations is back office. Airport operations is ecosystem. It's not the airline. It's the ecosystem the airline operates in. And you can look at, I can just give you two examples, right? Reduction in lobby staff through self-service check-in, right? We all have gone to airports and there's self-service, but it's positioning the self-service kiosks. And can we do that dynamically? Depending on the day of the week, depending on how many passengers check in, depending on which gates the passengers come in to check in. Because, remember, I am rushing to catch my flight. If my self-service kiosk is far away I will go to the check-in desk and check in. That's my human tendency. Now, the gates that I'm going to use to catch my flight will vary, because that's not in my control as an airline. Optimization problem. So that's what they've done using AI/ML, for instance, right? The other example is mishandled bags. We all have faced situations where bags have not arrived on time. So here, we have examples where if a bag is not on the same flight, it's automatically decided by an AI algorithm which other flight the bag needs to be routed through so that they can reach along with the passenger. Very, very complex problem. Thousands of flights, millions of bags in a day. Big, big impact on customer satisfaction. We live in a digital world. if I log into an airline review, you know what you see? The comments will be mostly related to food on the flight and whether my bag arrived on time. These are the two things. If you do everything right, but your bag does not arrive on time, you will hate your experience. And you will remember it for 10 years. I did. For 10 years, I did not fly that particular airline because my bag did not arrive, and I did not have my suit with me, and I had 3 important business meetings that I had to go through. I did not fly that airline for 3 years, multiple years. So the other key thing is they did not do everything big bang. They identified an opportunity. They got all the data in, what I talked about. Then they talked about where I can add business value, and they did it incrementally. This one, another example, and again, real world. This is a petrochem refinery or a petrochemical industry, in fact, in India. But here, you look at what's in this. I don't know whether this has a laser pointer, but right there, you have something called a real-time optimizer. What has happened here is we have built a digital twin of our process. And a refinery is like a city, right? You go in and then you have all this process equipment. But then, it's very, very expensive if you make the wrong decision. If you make the wrong decision, you may lose crores in terms of a day. The problem is opportunity loss. You don't know whether you are losing crores because unless you try out something new, you won't be able to figure out that you may have made more money. It's very expensive to do in the real world because of the time it takes and the expertise it takes. If you have AI-based digital twins, and this is where generative AI, we have things like GAN, right? Generative adversarial networks, where we are looking at ChatGPT-based, kind of ChatGPT-based algorithms, but we're augmenting that based on a model where the AI predicts an outcome, we are comparing it with the actual outcome. And then it's like, there's a lot of press going on in terms of Bollywood actresses and whether the pictures are fake or not. I don't know whether you have picked that up in your social media feeds. So there's generative AI. The bad thing is you can use that to produce fake images. If you use that positively, you can actually try to use generative AI to come up with, in this case, all possible combinations of the plant, which will actually lead to better yield. And then you have another AI working in tandem and saying that, okay, that's realistic, but that's fake. That recommendation will not work. I'm just trying to explain it to you. It's slightly more complex than that. But look at this. If I can do this I can do a digital twin of pretty much any complex process industry model. And those of you who are in the manufacturing world, this is a big opportunity for you. And it's not just process. It could be anything that we are trying to model. The fun part is, previously, we used to have to understand the chemical engineering processes for this. I had to be a chemical engineer to understand. But with the AI, it will figure it out. One issue there, which we are still trying to work on, is the explainability part of it. Because if I have a chemical engineer working on it, it'll be easier to explain. If not, that's that. But the message I'm leaving here is, these are real examples where we are adding a lot of value to digital transformation. That's all I had to say today. I don't know whether I'm out of time or whether there's any room for questions. Yeah. Yeah.
Thank you very much, Mr. Koushik Basu. May I request Mr. Oman Thomas, National Head of Advertisement Sales, ABP Private Limited, to kindly come forward and present a memento to Mr. Koushik Basu.
Thank you very much. Thank you.
A round of applause for
Thank
Mr.
you.
Koushik Basu for sharing those valuable information with us. Thank you very much, sir, for your interesting presentation.
Thank you.
Thank you.
Thank you very much.
And thank you, Mr. Oman Thomas.